Good morning to everyone. This is Nagur Miravali. Welcome to online class of mathematics of first B.Sc first semester. Okay, in this video we are going to discuss about the partial differentiation concept. Already in previous video I have done a definition of I have given a partial derivative differentiation definition, and in this video we are going to discuss about the partial differentiation and procedure to find the partial differentiations. Next one, first and second order partial differentiations. How to find what is the first order and second order partial derivatives. Okay. After discussing about the orders of the partial derivatives, next we are going to start the how to solve the given problems. That means how to find the partial derivatives with respect to the corresponding variables. Okay. Let's start the concept. Okay, students. Let's start the partial derivatives concept here. So partial differentiations. So already I have explained you about the function of two variables. For example, consider a function f of x is equal to 2 sine square x plus 4 log x plus e to the power of x square plus 1. So this is the function will be given. Observe students, this is the important content. How to find the derivative of this function with respect to the variable given. So what is the function? It contains the variable. So here if you observe here this total function will be in the variable x. Okay, this is a function in the variable x. Okay, so if you want to differentiating this function, we have to do the derivative with respect to x. Suppose I am going to differentiating this one here, differentiating with respect to x on both sides. We can differentiating like this. F of x derivative is f dash of x. Before going to differentiate this function, here there will be the plus values are there, so we can separate the derivative of this function. Before going to separation of the function, we have to write the any numerical constants before derivative, that is derivative of sine square x. Okay, plus here 4 into derivative of log x plus derivative of e to the power of x square plus 1. Okay, so we have a formula 2 into derivative of sine square x means this will be of the form x to the power of n, that means n into x to the power of n minus 1 means sine power 1 x into again derivative of sine x. Okay, we can write this one. After that 4 into derivative of log x is 1 by x plus derivative of e to the power of something, that will be of the form e power x derivative e power x. Again we can differentiating in the place of x what is there. Okay, if you simplifying like that, 4 sin x into derivative of sin x will be the cos x plus 4 by x is there plus e to the power of x square plus 1. Okay, into derivative of x square means 2x and derivative of 1 means 0, constant is 0. This is the general derivative of the function. Okay, so look at here, in previous classes we had differentiate a function whenever it will be only in one variable. Okay, we had differentiated a function in one variable. Such type of functions, they are one variable functions in the previous classes. In the previous classes means in intermediate level we had differentiated in one variable functions. Okay, this is the procedure to one variable functions. Now we are in the degree concept. So here just we had finished in the previous video about the function of two variables. So two variable means, let us consider a function here 2xy plus y square plus 2x sin square y plus log of x square plus y square is there. Okay, let us consider the function here. If you observe this function, how many variables you have seen here? Okay, we have seen here two variables. So first we have to take this one, f of xy. So function in two variables, they are the variables x comma y. So that's why we have to keep the name f of xy is equal to 2x, this one. So like that we have taken here. If you want to do the differentiation of this function, our question mark will be the we are going to whether we are going to differentiating with respect to x or with respect to y. Because of you have seen in this problem there are two variables are there. So that's why this function can be differentiated with respect to x variable and with respect to y variable. Okay, whenever you have seen a function in the two variables, now we can differentiate of that function with respect to two variables. That means, so what are the two variables here? X variable is there and y variable is there. So to differentiating this function, we are going to differentiating with respect to x or with respect to y. So if two variables you have seen, you are going to differentiate corresponding with respect to the corresponding variables. Such type of differentiation are called the partial differentiation. One note point will be there here. If you want to go to differentiate of the given function with respect to x variable, then the remaining variable, what is there? Y variable. That variable can be treated as the constant. What is that? Constant. In the same process, if you want to go to differentiate of the given function with respect to the y variable, now the remaining variable, what is there? X variable. That can be treated as the constant. Okay, students, this is the most important thing you have to do this one. Okay, let me start how to differentiate of this function with respect to x and with respect to y. Okay, suppose this is the equation 1. If you want to go to differentiate this equation 1 with respect to x here, now here differentiating 1 with respect to x partially. What is that? Partially. Already in the given problem can be seen here. We are going to differentiating partially or directly ordinary differential equation, ordinary derivative. Here there doesn't exist the ordinary derivative because of this function involving more than one variable. Then we can only differentiate of this function partially. So either of the variables. Suppose I am going to differentiating this one with respect to x here. So simply partial derivative can be written as dou by dou x of f. So simply you can write here f of xy as f here. Now dou by dou x of 2xy plus y square plus 2x sin square y plus log of x square plus y square. So just I have told you. So dou f by dou x can be written as simply f at x. That means partial derivative of the function f with respect to x. So here this can be simply written dou f by dou x as f at x here. Now dou by dou x of this one. Now we are going to differentiate this one. So here our corresponding our taken variable is the x variable. Now how many variables this function you have seen? Two variables. While you are going to differentiate with respect to the x variable, the remaining variable whatever it is there, that is y variable, that can be treated as the constant. Okay students, so now if you want to differentiate this one, here the constant of this one is we are going to differentiate with respect to x. Here the constant terms are 2 and y. You can write before that one 2y, and differentiating x with respect to x, you will get 1. same process, coming to the second term, here y square is there, but here there is no x variable. There is no x variable. So we are going to differentiate with respect to x here, differentiating with respect to x. But in second term, if you observe that there is no x term, so that's why this term will be considered as constant. Now we know that the derivative of constant is 0. Plus, here what should be the constant here in this one? Here sine square y is the constant. Now you can take this one before the derivative, sine square y, and constant is 2 is there here. Now, okay. Now, if you take in 2 sine square y as the constant, before write this one before the derivative. Now the derivative of x is equal to 1. Next concept, we are going to differentiate the log of something. In log of something, you have to observe there will be any x variable or not. Because of I am going to differentiating with respect to x variable. If there is no x variable are there in this function, you can treat it as a constant. But here if you see log of x square plus y square, it will contain the x term also, x variable also. So that's why you can differentiating log function, you will get 1 by x, that is 1 by x square plus y square. Again you can differentiating with respect to x what the function you have seen in the value of x. Now f at x is equal to 2y plus 0 plus 2 sine square y plus 1 by x square plus y square. And if you differentiating with respect to x here, derivative of x square, here we are going to differentiate with respect to x, you get 2x plus y square derivative with respect to x is 0. Y can be treated as constant. This is the derivative of the function with respect to x. Okay. Now in the same process, I am going to differentiating the same function with respect to y. So look at here, carefully observe that. So differentiating with respect to y, I am going to write directly here. Now it's said to be the f at y. Okay. Now for differentiating of 2xy means you have to write the constant numbers in this one. While you are going to differentiating with respect to y, you can treat it x as the constant. Now you can write 2x and derivative of y with respect to y is equal to 1 plus here derivative of y square with respect to y means now 2y n into x to the power of n minus 1 formula, but you can treat x as y here. Next plus you are going to differentiating with respect to y here. Now remaining variable, what is that? 2x, that can be treated as constant into sine square y. Derivative of sine square y means this will be in the form of x to the power of n into x means this one to the power of n minus 1 means 1 into y. Again derivative of sine y. Sine y derivative means cos y plus next derivative of log of something with respect to y. You can observe that it function will contain the y term or not. If it will be y term, you can write the log derivative. Derivative of log x is equal to 1 by x. The same process, dou by dou y of x square plus y square you can write here. Now 2x plus 2y plus 4x into sine y into cos y plus 1 by x square plus y square into derivative of 2x. Derivative of x square with respect to y means 0. Derivative of y square with respect to y means 2y. Okay, this is the procedure to differentiate the partial derivatives. Okay, in the same process we are going to discuss about the first order partial derivatives and second order partial derivatives. What is that? First order and second order partial derivatives. So let's note down the definitions of this one. First order and second order partial derivatives. Okay, suppose let us consider a function z is equal to f of xy be a function in two variables x and y. If you differentiating this function z with respect to, if you want to differentiate this function, you are going to differentiate with respect to either x or either y. Suppose you can differentiating with respect to x for the function z, you will get dou z by dou x. Or if you want to differentiating this function with respect to y, partially dou y by dou z by dou y. So they can also written as simply this is as z at x, z at y. So how many times you have differentiate here z either of the variable? Only one time. So they are called the first order partial derivatives. Okay, okay students, I hope you understand what are the first order partial derivatives. Okay, so let's write here y, the derivatives, the partial derivatives, partial derivatives z at x are dou z by dou x and z at y. So this can written as dou z by dou y are called the first order partial derivatives. First order means one time differentiation either of the variable. Okay students, now suppose if you differentiating z with respect to x here, you can get z at x, or simply this can be written as dou z by dou x. If you want to differentiate this function again either of the variable, that means first I am going to take this one dou z by dou x and going to differentiating with respect to x. This function is said to be this one. This can be written as dou square z by dou x square. Okay, or this function may be differentiate with respect to this function will be differentiating with respect to y. You will get dou z by dou y of dou z by dou x. That means dou square z by dou y dou x. Okay, one more thing, if you want to differentiating z with respect to y, it will be the z at y, or this can be written as dou z by dou y. This is the one time derivative with respect to y. Suppose if you want to go to differentiate this function with respect to x, that means you have to take dou by dou x. So this may also written as dou square z by dou x dou y. Okay, otherwise if you want to again differentiate the function dou z by dou y with respect to y here, you can get here dou square z by dou y square. Okay, so these four things are, what are the four things here? This one and this one, this one and this one. They are called the second order partial derivatives of z. So how many second order partial derivatives of z are there? Here this one with respect derivative of z with respect to x twice. This one derivative of z two times. One time is x, one time is y. Here also derivative of z with respect to one time x, one time y. Here also the derivative of z with respect to y twice. Okay, so in this one almost these two derivatives are equal. That means if you differentiate a function with respect to x again with respect to y, or the derivative of a function with respect to y, then with respect to x, they both are equal. Okay, now we can say that these four derivatives are called the second order partial derivatives. Okay students, next write down the definition of second order partial derivatives. Okay, now the same process, the partial derivatives z at x, or this can be written as dou square z by dou x square, comma z at x y. This can also written as dou z by dou y dou x. Okay, first x after y. Next, comma z at x y, or this can also written as dou z by dou y dou x, and z at y comma y. Y means this can also written as z at y square. Okay, or this can also written as dou square z by dou y square, are called the second order partial derivatives. Second order partial derivatives. Okay students, they are the first order partial derivatives and second order partial derivatives. If you want to find the first order partial derivatives, it is enough to find a function, the derivative of that function with respect to x one time, and again with respect to y one time. Okay, so they are called the first order partial derivatives. If you want to find the second order partial derivatives, means you can differentiating the given function two times. Okay, if whatever you have to possible, you can do either x either y. So there will be four partial derivatives, four second order partial derivatives are there. They are derivative of that function with respect to x twice, derivative of a function with respect to y twice, derivative of a function twice, one time x one time y. Okay, so they are the second order and first order partial derivatives. Okay, let me start the problem on this model. First problem, find the first order partial derivatives of tan inverse of x plus y. Okay, this is the question we have given. So solution I am going to write here. So what is the given function? You have seen tan inverse of x plus y. So let us take the given function z is equal to tan inverse of x plus y. So this is the given function. What we are going to find here? First order partial derivatives. First order partial derivative means we can differentiating this function one time x, again differentiating the same function with respect to y. That means first order partial derivatives means dou z by dou x and dou z by dou y. Okay, so z can be differentiating one time x, so that is the one first order partial derivative. Next, derivative of z with respect to y, you will get the another first order partial derivative, that is we have to find here. So that means we are going to find the derivative of first one with respect to x. Now differentiating one with respect to x partially. Okay, now dou by dou z, sorry, dou by dou x Dou by dou x of z is equal to dou by dou x of tan inverse of x plus y. Okay, now this can be simply written as z at x is equal to derivative of tan inverse x, but you have to observe that whether this tan inverse function will having the x value, x variable or not. If there is no x variable, you can treat it as a constant. Now this will be tan inverse x formula 1 by 1 plus x square. That means x plus y whole square. Again we can differentiating with respect to x of the tan inverse function. Now z at x is equal to 1 by 1 plus x plus y whole square into again derivative of x plus y. Derivative of x plus y means derivative of x with respect to x is 1. Now derivative of y with respect to x means 0, because of if you differentiating with respect to x, y can be treated as the constant. Okay, now you can simplifying this one, you will get 1 by 1 plus x plus y whole square means x square plus y square plus 2xy, and 1 plus 0 means 1. So you will get this is the first order partial derivative with respect to x. Again we have to find the first order partial derivative with respect to y. So therefore z at x is equal to 1 by 1 plus x square plus y square plus 2xy. This is equation number 2. So to get derivative of z with respect to y, again we have to differentiating 1 with respect to y here. Now differentiating 1 with respect to y. Now dou by dou y of z is equal to dou by dou y of tan inverse of x plus y. So that is z at y is equal to derivative of tan inverse x. Again you are going to differentiate with respect to y here. In this one it will containing the y variable also. Now we can write here 1 by 1 plus x square means x plus y whole square. Again differentiating with respect to y, x plus y. Okay, now if you continuing this process, z at y by 1 by 1 plus this is x square plus y square plus 2xy. Next derivative of x means 1 0, because of you are going to differentiate here 1 y. Here x variable can be treated as constant. Now derivative of constant 0. Now derivative of y with respect to y is 1. So finally you can get z at y is equal to 1 by 1 plus x square plus y square plus 2xy. 1 plus 0 1. Okay, this is equation number 3. Now here these two are the second one and third one are the first order partial derivatives. Okay, this is the problem here. Next one, in the same way we are going to find another problem. First you have to note this problem carefully. Okay students, now another problem we are going to take. Okay, second problem. Find the first order partial derivative of e to the power of ax into sin by. Okay, this is the problem you have seen here. Look at here students, given function you have to take, given that z is equal to e to the power of ax and sin by. This is equation 1. Now already just I have told you the first order partial derivative means z at x and z at y. they are the first order partial derivatives. Okay, now I am going to differentiate the one with respect to x and with respect to y. Okay, now differentiating one with respect to x partially. Now what you get, dou z by dou x is equal to dou by dou x of e to the power of ax into sine by. Okay, now this will be z at x. Suppose here you are going to differentiating with respect to x, the terms which does not having the x value, x variable, they can be treated as constant. So here the constant term will be the this one, because of it does not having the x value. So that's why you have to write sine by, again dou by dou x of e to the power of ax. So now z at x is equal to sine by into derivative of e power x means e power x. Again you can differentiating with respect to x, exponential function. Okay, now z at x is equal to e to the power of ax into sine by into, here derivative of ax means a is the constant and x is the variable, derivative of x is 1. So finally you can write here z at x is equal to a into 1 a into a power x and sine by. Okay, this is the derivative of x, derivative of z with respect to x. Now in the same process we are going to take this function equation 1 with respect to y here. Okay, another first order partial derivative is that one. Now differentiating, we are going to write here, do the problem. Differentiating 1 with respect to y partially. Now we can get here dou z by dou y, dou by dou y of z is equal to dou by dou y of e power ax into sine by here. Now observe carefully, you are going to differentiate with respect to y, so that means you can treat x as the constant. So here the x is there, that can be taken as constant, and second function will be having y variable that can be written, that can be differentiate with respect to y here. Now you can get e power ax into derivative of sine means cos into function can be differentiating with respect to y. Now by, so that is z at y is equal to e power ax into cos by into, here b is the constant, derivative of y means respect to y 1. So now finally z at y is equal to b into e power ax into cos by. Okay, this is the first order partial derivatives. Okay, this one and this one, they both are the first order partial derivatives. Okay students, I hope you understand this procedure. I am going to give you one problem as homework. Okay, do this one. So take this problem as homework. Okay, find the first order partial derivatives of log of x square plus y square. Okay, take this problem as the homework. Okay students, we will meet in the next class another model, that means second order partial derivatives. Okay, we will continue in the next class. Okay students.